Hi guys, let's discuss the questions based upon JEE Advanced pattern from trigonometric functions. The first question is saying which of the statement or statements is or are true. So, cos theta, cos of sine theta is greater than or equal to sine of cos theta. Now over here, mind it, it is given to you whether this is true or not. Cos of sine theta is greater than or equal to sine of cos theta. Fine. And theta generally is taken in the principal domain only, which is minus or basically 0 to pi by 2. We can take minus pi by 2 to pi by 2 as well, but generally it will be given to you to be 0 to pi by 2. Now over here, this is what you have to prove, or you have to show whether it is true or it is false, provided the range of theta is this. So over here, if I consider sine theta plus cos theta, there is a very famous fashion in which this expression can be written, which is root 2 1 by root 2 sine theta plus 1 by root 2 cos theta, alternatively. And because I know cos pi by 4, sine pi by 4, both are 1 by root 2, I can further transform it as cos pi by 4 sine theta plus sine pi by 4 cos theta. So it's almost like sine A cos B plus cos A sine B, that's sine of A plus B. So root 2 sine of pi by 4 plus theta. Now you know sine of any angle is always less than or equal to 1, right? Sine ratio's maximum value attained can be 1. So sine of pi by 4 plus theta will be less than or equal to 1. So root 2 times sine of pi by 4 plus theta will be less than or equal to root 2 into 1, which is root 2. So what basically you have got is sine theta plus cos theta is less than or equal to root 2. Sine theta plus cos theta is less than or equal to root 2. If this is what I have got, cos theta, can I write cos? Cos theta can be written as less than or equal to this, but rather it would be better if instead of root 2 we try to incorporate something like allied angle, and because of that only you know root 2 is less than or equal to pi by 2, isn't it? Definitely. This is 1.414, whereas this is 1.57, right? This is what it is, and therefore rather than root 2 I can convert it into pi by 2, and so this gives me pi by 2 minus sine theta. Now see, whenever you have the graph of the cosine function, it is like this in the range minus pi by 2, pi by 2. And from 0 to pi by 2, if I primarily focus, cos theta is from 0 to 1. So cos theta is from 0 to 1 when theta is in 0 to pi by 2. Over here also you are going to see this is how the sine function is from 0 to pi. At pi by 2 it's 1, pi by 2 is 1.57. Fine. So cos theta is lying from 0 to 1, somewhere between 0 to pi by 2 only. And in fact, if theta is from 0 to pi by 2, you won't believe pi by 2 minus sine theta is also here itself from 0 to pi by 2. That means this is also 0 to pi by 2. This entirely is also ranging from 0 to pi by 2. In the range of 0 to pi by 2, sine theta is an increasing function. See, from 0 to pi by 2, sine theta is an increasing function. Therefore, if cos theta is less than equal to pi by 2 minus sin theta, therefore, sine of cos theta is less than equal to sine of pi by 2 minus sin theta. Now, what is 90 minus sine of 90 minus theta? Cos theta. And so you get sine of cos theta is less than equal to. So this is what? Here it will be sine of cos theta is less than equal to sine of 90 minus sin theta. Now see, sine 90 minus theta happens to be cos theta. So this will be cos of sine theta, right? Sine 90 minus theta is cos theta. Here theta is being played by sine theta. Fine. And here you have, as it is LHS, sine of cos theta. That means sine of cos theta is less than equal to cos of sine theta. Sine of cos theta is less than equal to cos of sine theta. That means yes, it is very much true. Let's move to the second. It says sine 1 is less than sine 2. Is that true or not? Let's try to see. Sine 1 is less than sine 2. Now over here one thing should be clear. If 1 and 2 are given to you, they are given in radians and not in degrees. Fine? Now if I begin to plot the graph of sine, from 0, pi, this is somewhere pi by 2. Pi by 2 is what? 1.57. Pi is what? 3.14. So 1 will be where? 1 will be somewhere here, somewhere before pi by 2. So you have got sine 1 is coming a value to be like this. This is sine 1. Now you know sine of pi minus theta is same as sine theta. Whatever is sine 1, same as sine of pi minus 1. Sine 1 is same as sine of pi minus 1. That means sine of 3.14 minus 1, that means sine of 2.14. So that means pi minus 1 is 2.14. If pi minus 1 is 2.14, somewhere before pi minus 1 is 2. So here somewhere is 2, definitely corresponding to 2, the graph of the function is at a higher point, and therefore this is what is your sine 2, and therefore you get that as corresponding to 2, graph of sin x is at a higher point therefore sin 1 is less than sin 2. So we have corresponding to 2, graph of sin x is at a higher point than sin 1, therefore sin 1 is less than sin 2. So that means even this is true. That means definitely this is not true. Let's just check if cos 1 is less than cos 2 or not. Sin 1 is less than sin 2. What about cos 1 is less than cos 2? Okay. So basically, this is how you obtain in the portion 0, pi by 2, pi, right? Pi by 2 is 1.57, so 1 is somewhere here. Corresponding to 1, this is your cos 1, right? Pi is 3.14, pi by 2 is 1.57, so 2 is somewhere here. Corresponding to 2, this is your cos 2. Clearly you can see cos 2 is negative, cos 1 is positive, therefore cos 2 is less than cos 1 or cos 1 is greater than cos 2. So sin 1 is less than sin 2 but cos 1 is greater than cos 2 and that is why option number D is wrong. Understood? That is how you deal with questions like these which actually concern greater than or less than equal to in terms of trigonometric values. Let's watch out for the next question. Okay, so the function given to me over here is from -1, 1 open interval to collection of all reals be such that f of cos 4 theta is equal to 2 upon 2 minus sec square theta for theta belonging to a certain domain of points. Further, the question says then the value or values of f of 1 by 3 is or are what? Now see, it's given f of cos 4 theta, asked is f of 1 by 3. That means cos 4 theta has to be equal to 1 by 3 for f of cos 4 theta to be equal to f of 1 by 3. For cos 4 theta to be equal to 1 by 3, what is it that should happen? So whenever cos 4 theta will be equal to 1 by 3, this means what? Twice of 2 theta is 1 by 3. Now you know 1 plus cos 2 theta is 2 cos square theta. So cos 2 theta is 2 cos square theta minus 1. 2 cos square theta minus 1 is 1 by 3 because this is playing the role of theta. Cos 2 theta is 2 cos square theta minus 1. So this means what? This will be 2 cos square 2 theta equals 1 by 3 plus 1, which is what? 4 by 3. So this will be cos square 2 theta will be 4 by 6, which is 2 by 3, and therefore cos 2 theta will be equal to plus minus root over 2 by 3. So if cos 4 theta is equal to 1 by 3, cos 2 theta is equals to plus minus root 2 by 3. This is sure. If I want this to be equal to this, this is going to hold for sure. Now, therefore, f of 1 by 3 is f of cos 4 theta. Why? Because I am taking cos 4 theta to be 1 by 3. That means I am taking that this situation is happening. So if cos 4 theta is 1 by 3, f of 1 by 3 is f of cos 4 theta, which is given to me as what? 2 upon 2 minus sec squared theta, which means 2 upon 2 minus 1 upon cos squared theta, which means what? 2 cos squared theta upon 2 cos squared theta minus 1, right? Now you know 1 plus cos 2 theta is 2 cos squared theta. So this will be 1 plus cos 2 theta whole upon. Again, 1 plus cos 2 theta is 2 cos squared theta. So 2 cos squared theta minus 1 is cos 2 theta. Right? Now, because 1 by 3 I had taken equal to cos 4 theta, that means cos 2 theta was plus minus root over 2 by 3. This further simplification gives me 1 plus 1 by cos 2 theta. Now, cos 2 theta is what? Plus minus root 2 by root 3. So, its reciprocal will be 1 plus minus root 3 by root 2. Cos 2 theta is root 2 by root 3. So, 1 upon cos 2 theta will be root 3 by root 2 with plus minus. That means f of 1 by 3 can be 1 plus root over 3 by 2 or 1 minus whole root over 3 by 2. And therefore, this is what you get as your solutions, 1 minus root over 3 by 2 and 1 plus root over 3 by 2, not this and not this, because reciprocal is coming over here. Fine, easy question, just understand the concept that when cos 4 theta will be equal to 1 by 3, then what is it that is going to be true? Use that and you get your result. Let's watch out for the next question. Question number 3 says, if Sine 4x plus cos 4x by 3. So this expression is given to us is equal to 1 by 5. Then they are asking for the values to be computed. Okay, let's watch out for the expression. Sine 4x by 2 plus cos 4x by 3 equals 1 by 5. Fine? Now, just take the LCM and cross multiply. What you get? 3 sine to the power 4x plus 2 cos to the power 4x whole upon 6 is 1 by 5. Fine? 3 sine 4x plus 2 cos 4x. Cross multiply, you get 15 sine 4x plus 10 cos 4x equals 6. 5 into 2, 10, 5 into 3, 15. Now, the moment you see even powers with sine and cos, you know sine square theta plus cos square theta is 1. So, cos square theta is 1 minus sine square theta. I can write it that. This is 15 sine to the power 4x plus 10 cos square x whole square. Right? So, because sine square x plus cos square x is 1, cos square x is 1 minus sine square x. So, 1 minus sine square x whole square equals 6. So, this gives me what? 15 sine 4x plus 10 into a square plus b square minus 2ab equals 6. Fine. Now, simplify further. You have 15 sine 4x plus 10 sine 4x minus 8 sine square x, right? 10, that's 20, not 8, that's 20, minus 10 into 2, 20 sine square x equals 6. This means what? Now see, 15 sine 4x plus 10 sine 4x gives you 25 sine 4x minus 20 sine square x fine. Then you have plus 10 minus 6, that's plus 4 equals 0. You have a quadratic equation in sine square x. Yes, because if I take sine square x equals t, what you get is 25t square minus 20t plus 4 equals 0. Now what is this? Perfect square. 5t minus 2 whole square is 0. 25t square plus 4 minus 5 into 2, 10, 10 into 2, 20t. This is what you have. This means 5t minus 2 is 0. That means t is 2 by 5, which means sine square x is 2 by 5. The question is, compute the value of tan square x. Is it 2 by 3 or is it 1 by 3? Is this or this? And then compute the value of this expression. Is it 1 by 125 or 2 by 125? So let's compute tan square x. I have sine square x. What will be cos square x? Sine square x plus cos square x is 1. So 1 minus sine square x is cos square x. So 1 minus 2 by 5, which is 3 by 5. If sine square x is 2 by 5, cos square x is 3 by 5, tan square x is 2 by 5 upon 3 by 5, which means 2 by 3, and therefore you have your answer that it is not equal to 1 by 3, but in fact it's equal to 2 by 3. The next expression is sine 8x upon 8 plus cos 8x upon 27. So, sine 8x upon 8 plus cos 8x upon 27. I can write it like this. Why have I written it like this? Because I know the values of sine square x and cos square x. Sine square x is 2 by 5. So 2 by 5 whole to the power 4. 2 multiplied by 4 gives you 16 and 5 multiplied by 4 gives you 625 multiplied by 8 plus then you have 3 by 5 whole to the power 4, that gives you 81 upon 625 into 27, which eventually gives you 5 upon 625 or 1 upon 125, and therefore sin 8x upon 8 plus cos to the power 8x upon 27 is 1 by 125 and not 2 by 125. Fine. Pretty nice question this was. We just had to simplify it to get a quadratic equation in sine square x. The moment I got sine square x, after that the question is nothing. We are just substituting the value of sine square x, cos square x to get the further values. Fine. Okay, let's see what happens to be the next question. Here I am given theta is an angle from 0 to pi by 4. T1 is something, T2 is something, T3 is something, T4 is something. The point is, everything is given in terms of tan and cot when angle is lying from 0 to pi by 4. Okay, so for that, we need to be very well aware about the graph of tan and the graph of cot. So, if I talk about tan x, well, this is how the graph of tan x goes if I am just talking in minus pi by 2, pi by 2. Fine, this is pi by 2, this is 0. You know tan pi by 4 is 1, right? Tan pi by 4 is 1. So, if x is ranging from 0 to pi by 4, tan x is ranging from 0 to 1. So, tan theta belongs to 0, 1. Pi by 4 is not included, 0 is not included. So, tan 0 and tan pi by 4 are also not included. Fine. Whereas, alternatively, if I talk about cot, how does cot behave? Right? This is 0, this is pi by 2, this is pi by 4. This is pi by 4, cot pi by 4 is 1, right? So, understand, if x ranges from 0 to pi by 4, cot function is from 1 to infinity. So, if theta ranges from 0 to pi by 4, cot theta ranges from 1 to infinity. Fine. That means tan theta is a fractional value, whereas cot theta is any number greater than 1. Fine. Fractional means it's definitely less than 1 from 0 to 1, and this is a number greater than 1. Now see what is given to you. T1 is tan theta to the power tan theta. Fractional to the power fractional. T2 is what? Tan theta to the power cot theta. Fractional to the power number greater than 1. What is T3? Cot theta to the power tan theta. Number greater than 1 to the power fractional. T4 is cot theta. Here it would have been cot theta to the power cot theta, because the question basically tried to give you number greater than 1 to the power number greater than 1. So, T4 is cot theta to the power cot theta. So, you have tan theta to the power tan theta, tan to the power cot, cot to the power tan and cot to the power cot. Fine. See, if I take a number greater than 1 to the power fractional value and number greater than 1 to the power number greater than 1. this is root 2 less than 2 and this is 4 greater than 2. That means number greater than 1 to the power fractional is less than number greater than 1 to the power number greater than 1. This means T3 is less than T4. Next, if I take 1 by 2, fractional to the power fractional is 1 by 4, which is less than 1 by 2. And fractional to the power number greater than 1. Here it would be number greater than 1. This is 1 by 4, which is less than 1 by 2. And if I take fractional to the power fractional, if I take fractional to the power fractional, this will be 1 by root 2, which you can write it as root 2 by root 2. So this will be root 2 by 2, which is greater than 1 by root 2. That means fractional to the power number greater than 1 is reducing it and fractional to the power fractional is increasing it. Even this number will be also less than 1, but definitely it will be greater than fractional to the power number greater than 1. So you have fractional to the power number greater than 1 is less than fractional to the power fractional. So fractional to the power number greater than 1 is less than fractional to the power fractional. So T2 is less than T1. Fine. T2 is less than T1, T3 is less than T4. What about T3 and T2, right? So basically I have to compare among these now. Which number will be the smallest? Whose base is the smallest? Here the base is fractional, here the base is number greater than 1. So numbers with fractional base are less than numbers with greater than 1 as their base. So T3, T4 both are less than T1, T2. That means what? How can I write it? T3 is less than T4, T4 is less than T2 is less than T1. T3 is less than T4, T4 is less than T2 and T2 is less than T1. Can I write it like this? This is T3. No. I cannot write it like this. T2 and T1 are representing fractional values and T3 and T4 are representing base as greater than 1. So you have T2 less than T1, T1 is less than T3, which is less than T4. Fine. T2 is less than T1, fine. Both of them are less than T3 and T4, but because T3 is less than T4, therefore T2 less than T1, less than T3, less than T4, or T4 greater than T3, greater than T1, greater than T2. Let's see what is the answer. This happens to be the answer. T4 greater than T3, greater than T1, greater than T2. That is what we had got. And so this is the correct one. So here basically what we used is the fact that tan theta is belonging to 0 to 1, that means it's a fractional value, whereas if cot theta is belonging to 1 comma infinity, it's a number greater than 1, and that gave us such a conclusion. Alternatively, I can write it as T4 is greater than T3, is greater than T1, is greater than T2, the way it is written in your option number B. Fine? Now, let's see what is the next question. It is saying the smallest positive root of tan x minus x equals 0 lies in which quadrant? Okay, so there is a function given to me, tan x minus x. Let's take fx to be equal to tan x minus x. Okay? Okay, so let's look at the options. You have 0 to pi by 2, pi by 2 to pi, pi to 3 pi by 2, 3 pi by 2 to 2 pi. That means basically you just need to analyze this function's behavior from 0 to 2 pi. So fx is equals to this for all x belonging to 0 to 2 pi. I have to find all those x's where tan x minus x is 0, that means f of that x is 0. Let's begin with the first portion of 0 to 2 pi, that is 0 to pi by 2. If x belongs to 0 to pi by 2, now see. This is how the tan function goes from 0 to pi by 2. This is 0, this is pi by 2, right? At pi by 4, the tan is giving you value 1. And pi by 4 is less than 1. So when the identity function is going to be plotted, this is identity function, isn't it? This is y equals tan x, this is y equals x. So basically if I am saying at what axis tan x minus x should be 0, I am saying at what axis tan x should be equal to x. Tan x is this. If x is belonging to 0 to pi by 2, the function x is going to go less than tan x, or tan x will be greater than x, because at pi by 4 the identity function will be giving you pi by 4 which is less than 1. This is just a very motivation that tan x will be greater than x for x belonging to 0 to pi by 2. So here tan x will be greater than x. This implies tan x minus x is greater than 0 for all x belonging to 0 to pi by 2. This 0 and pi by 2, they are not included. So over here for all x belonging to 0 to pi by 2, tan x minus x is positive. This implies fx is positive for all x belonging to 0 to pi by 2. If fx is positive for all these x's, that means it is not 0. There is no root lying in 0 to pi by 2 for the function f. So 0 to pi by 2 is definitely not the answer. There is no root lying in 0 to pi by 2. There is no x in 0 comma pi by 2 where tan x minus x can be 0 or tan x is equal to x. Okay, and 0 is not included, mind it. 0 is not included. Next, if I talk about pi by 2 to pi, how does tan function is? This is how it is. So 0, pi by 2, pi, 3 pi by 2. From pi by 2 to pi, tan function is negative. Or you can say in the second quadrant tan is negative. Whereas if you are going to plot the identity function, it will definitely be greater than tan x. So this means when x belongs to pi by 2 to pi, x is greater than tan x, right? Tan x is here, x would be somewhere here. Fine. Therefore, tan x minus x is less than 0, or fx is less than 0 for all x belonging to pi by 2 to pi. If it is less than 0 for all x belonging to pi by 2 to pi, that means it's not equal to 0 for any x belonging to pi by 2 to pi. That means even this cannot be the answer. Let's see 3 pi by 2 to 2 pi. Okay, so 3 pi by 2 to 2 pi. This is your 2 pi. From 3 pi by 2 to 2 pi, also what is happening to the graph? This if you ignore, or basically first of all what you do is, don't forget what we did. We have accomplished the understanding of 0 to pi by 2. Then we had pi by 2 to pi. Then pi to 3 pi by 2, 3 pi by 2, 2 pi. So we still need to accomplish our understanding on these two intervals. So if I talk about the graph of the tan function, this is 1, complete form. This is another complete form. And then this is another complete form. Fine? This is my 0, that's pi by 2, pi, 3 pi by 2, 2 pi, and then 5 pi by 2 and so on. So over here we can see we have done from 0 to pi by 2, there is no solution. Pi by 2 to pi, no solution. Pi to 3 pi by 2, I don't know still, but 3 pi by 2, 2 pi if I am going to see, again the function is less than 0, that's negative. So 3 pi by 2, 2 pi is negative and x is greater than tan x. So for x belonging to 3 pi by 2, 2 pi, x is greater than tan x, which implies tan x minus x is less than 0. So fx is less than 0. That means it is not equal to 0. So definitely this is not the answer. What about pi to 3 pi by 2? Over here if you see pi to 3 pi by 2, let's try and observe. If x belongs to pi to 3 pi by 2, then what is f of pi? F of pi is tan pi minus pi. Tan pi is sin pi upon cos pi, 0 upon 1, that's 0. So this is 0 minus pi, which is less than 0. Next you have f of 3 pi by 2, which is tan of 3 pi by 2 minus pi, isn't it? Minus 3 pi by 2. Because it is tan x minus x. So tan 3 pi by 2 minus 3 pi by 2. At 3 pi by 2, tan is not defined. In fact, you can say it is taking a which value? So as x approaches 3 pi by 2, this is going to infinity. So this is very, very large value. From it, if you are removing 3 pi by 2, from a very large value, if you are removing 3 pi by 2, that means it is positive. So what you're getting? F of pi is negative, f of 3 pi by 2 is positive. That means the function f, if suppose this is 3 pi by 2, this is pi and then this is 3 pi by 2. At pi, it is negative. At 3 pi by 2, it's somewhere positive. You know tan function is continuous, identity function is continuous, difference of two continuous functions is continuous. So somehow when this f function is going to be plotted, it is definitely going to at least once cut the x-axis in the interval pi to 3 pi by 2. It can cut even more than once, but definitely because at one point it is negative, at one point it's positive and it is continuous, therefore at least once it is going to cut the x-axis. Fine, and the moment it is cutting x-axis, that means at that x, f of x will be 0. For that x, f of x will be 0, that means there is at least one root in pi to 3 pi by 2. There is at least one root, at least one root of the function fx in pi to 3 pi by 2. And therefore, this is bound to be your correct answer. Fine. That is how you deal with such a question. By graphical approach or by quadrant approach you can proceed, and therefore by basically segregating the entire interval 0, 2 pi into 4 different parts and then observing the pattern in each of the subintervals. Fine. Let's see what is the next question. Over here it's saying the solution set of the system of equations x plus y equals 2 pi by 3 cos x plus y equals 3 by 2, where x and y are real, is what? Okay, so I am already given x plus y is 2 pi by 3. which in degrees is 120 degrees. Fine. Then you have to compute cos x plus cos y equals 3 by 2. So cos x plus cos y equals 3 by 2. We have to find the solution set for this system. Fine. This and this. Now if x plus y is 2 pi by 3, this means I can write y as 2 pi by 3 minus x. And so this becomes cos x plus cos of 2 pi by 3 minus x equals 3 by 2. Fine. Now what is this? This is cos of a minus b, which is cos a cos b plus sin a sin b. Fine. Now what is cos 2 pi by 3? Cos 2 pi by 3 means cos 120. That's cos of 90 plus 30. Cos 90 plus theta is what? Sin 30 or minus sin 30? 90 plus theta lies in the second quadrant where cos is negative. So this will be minus sin 30, which is minus 1 by 2. Whereas sin 2 pi by 3, sin 120 is sin of 90 plus 30, which is just sin cos 30, sorry. This will be cos 30. Sin 90 plus theta is cos theta without any minus sign, which is root 3 by 2. And so what will be the expression? You have cos x, cos 2 pi by 3 is minus 1 by 2. So this is minus 1 by 2 cos x. Sin 2 pi by 3 is root 3 by 2 plus root 3 by 2 sin x equals 3 by 2. Cos x minus half cos x is half cos x plus root 3 by 2 sin x equals 3 by 2. Next, here, now see, I know that sine of pi by 6 is 1 by 2 and cos of pi by 6 is root 3 by 2. So I can alternatively write it as sine pi by 6 into cos x plus cos pi by 6 into sin x equals 3 by 2. Sin a cos b plus cos a sin b is sine of a plus b. And now comes the twist. 3 by 2 is 1.5, whereas sine of any angle is less than equal to 1 for every angle. Whatever this real number is, sine of this real number can never exceed 1. That means there does not exist any solution since sin x is less than equal to 1 for every real number x. But here it is coming out to be 1.5 and there is no such real number for which sine is 1.5 or greater than 1. And therefore the answer is no solution. Understood? That's how you deal with this question. Pretty simple and nice question, I would grade it as. Next question is the number of solutions of this particular equation 81 to the power sine square x plus 81 to the power cos square x equals 30 in the interval 0 to 2 pi are what? So, let's proceed in finding the solution of this trigonometric equation. It's given to me 81 sine square x plus 81 cos square x. Now see, generally people try to apply the logarithm approach to bring sine square x down, not in the power but rather in the base. But I will not be able to do that or expand it the way I wish to because log does not distribute over the sum. So I'm stuck. There is no logarithm approach which is going to help you to deal with this power related question. Instead, one thing which I recently said also, that here you can see sine and cos are occurring in even powers, and we have a very nice formula to convert sine into cos when it is occurring in even powers, which is sine square x plus cos square x is 1. So cos square x can be written as 1 minus sine square x, and therefore 81 sine square x plus 81 1 minus sine square x equals 30. Fine. So this becomes 81 sine square x plus 81 into 81 to the power minus sine square x, which is 81 to the power sine square x, which is equal to 30. Fine. Now what? Let sine square x be equal to t. So you get 81 to the power t plus 81 upon, or basically let me take 81 to the power sine square x to be equal to t. Let 81 to the power sine square x to be equal to t. So you get t plus 81 upon t equals 30, which gives you what? T square plus 81 equals 30t, which implies t square minus 30t plus 81 is 0. You can break the middle term. T square minus 27t minus 3t plus 81 equals 0. This is t minus 27 minus 3 t minus 27. This gives me t minus 27 and t minus 3 equals 0. This means t is 27 or t is 3. This means t is what? 81 to the power sine square x is 27. Let's deal with this first. 81 is what? 3 into 3, 9. 9 into 3, 27. 27 into 3 is 81. So this can be written as 3 to the power 4 sine square x equals 3 to the power 3. So you get, bases are same, equate the powers. 4 sine square x equals 3 sine x equals plus minus root 3 by 2. And over here if you see, 81 to the power sine square x equals 3. 81 can be written as 3 to the power 4. This equals 3 to the power 1. Bases are same, equate the powers. Sine square x is 1 by 4. Therefore, sine x is plus minus 1 by 2. What are the x's? Or basically the question is saying number of solutions. I am not interested in what are the solutions. I am just interested in number of solutions. So, how many x's are there for which sine x is plus root 3 by 2 or minus root 3 by 2? How many x's are there for which sine x is plus 1 by 2, minus 1 by 2? Let's see. Okay. So, in 0 to 2 pi basically I have to find out. That is given in the question. 0, pi and 2 pi. Now, you know 1 by 2 is somewhere here. Minus 1 by 2 is somewhere here. And therefore, how many x's are there for which sine x will be equal to 1 by 2? Well, if I pass a line y equals 1 by 2, I am seeing there are 2 x's for which sine x is equal to 1 by 2. If I talk about minus 1 by 2, again there are 2 x's for which sine x is equals to minus 1 by 2. That means there are 4 x's which are going to satisfy sine x equals to plus or minus 1 by 2. So there are 4 solutions from here. If I similarly talk about root 3 by 2 or minus root 3 by 2, root 3 by 2 is a number even less than 1 by 2. Again, you are going to see the exact same pattern. 2 times and 2 times, that means 4 solutions for here. So all those x's for which sin x is plus or minus root 3 by 2 or sin x is plus or minus 1 by 2, there are 8 solutions to this. Therefore, number of solutions is 8. Understood? Pretty nice question. I would grade it as this required a certain amount of thought, but after that it was pretty simple. Okay? Let's move further and see what is the next one. I am given in a triangle ABC, a point D is taken on side BC such that this, then the ratio of BD is to DC is being asked. Now, what is it related to? Let's try and find out. Okay, so let's make a generalized triangle ABC. This is A, this is B, and this is C. On the side BC, point D is taken in such a manner that angle ADC is 60. So somehow point D is taken so that here you get your 60 degrees. Angle DAC is given to be 45 and BAD is given to be 30 degrees. You have to find the ratio of BD is to DC. BD is to DC. Let the ratio be M is to N. Fine. Let BD is to DC be M is to N. Understood? The moment we talk about ratio, sides are given, angles are given in a certain fashion, they are given. There is what? If you remember the cotangent rule, you are going to get M plus N cot theta equals M cot alpha minus N cot beta, where your theta is 60 degrees, alpha is 30 degrees and beta is 45. Isn't this diagrammatic approach completely tallying with the cotangent rule approach? Theta is given, alpha is given, beta is given. Fine. And therefore, incorporate the values of theta, alpha, beta in the formula of cotangent rule. We are going to get our ratio of M by N. Let's see how. M plus N cot 60 is M cot 30 minus N cot 45. M plus N cot 60 is 1 by root 3, cot 30 is just root 3, cot 45 is 1. Multiply root 3 that side, you get M plus N equals 3M minus root 3N. Divide by N. Why? Because I want M by N. Divide throughout by N, you get M by N plus 1 equals 3M by N minus root 3. So you get 1 plus root 3 equals 3M by N minus M by N. 3M minus M gives you 2M by N. And so you get 1 plus root 3 is 2M by N. That means 1 plus root 3 by 2 is M by N. Therefore, M is to N is 1 plus root 3 is to 2. Understood? That is what is your ratio. 1 plus root 3 is to 2. Understood? That's how previously in the beginning it was not so natural that the cotangent rule will be used. But the moment the diagram was completed, the requirements which were given to me already were basically tallying my cotangent rule hypothesis, and by using that I have got my result. Understood? Okay, let's see what is our next one. It is saying the number of values of x in the interval 0 to 5 pi of this equation 3 sin square x minus 7 sin x plus 2 equals 0 is how many? Again, solutions are not being asked, number of solutions are being asked. Let's see, you have 3 sine square x minus 7 sine x plus 2 equals 0. Okay? Break the middle term. 3 sine square x minus 6 sine x minus sine x plus 2. Right? You can take out 3 sine x common. You are left with sine x minus 2 minus 1 sine x minus 2. Fine? This gives you what? Sine x minus 2, 3 sine x minus 1. Now see, if the product of two things is 0, either this is 0 or this is 0. But can this be 0 ever? Sine x minus 2 being 0, that means sine x is equal to 2. But sine x maximum to maximum can be 1, it can never be 2. So this can never be 0. If this is never 0, that means this is non-zero. But the product is 0, that means this has to be 0. So as sine x cannot be equal to 2, for the product to be 0, 3 sine x minus 1 will have to be 0. That means sine x will have to be 1 by 3. Now let's see, in 0 to 5 pi the question is, okay, 0 to 5 pi, 2 pi, 4 pi, 5 pi. So this is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Somewhere here is 1 by 3. You want to find out all those x's for which sine x is 1 by 3. Just plot the graph of sine x, which we have done in the range 0 to 5 pi. Plot the graph of y equals 1 by 3. See where these two are intersecting. Number of intersection points are going to give you the result. So this is how the straight line is going to go. In 0 to 5 pi, 1, 2, 3, 4, 5, 6. So there are x1, x2, x3, x4, x5 and x6. There are 6 x's from 0 to 5 pi at which sine x is equal to 1 by 3. So the solutions are 6 in number. Understood? Pretty easy question, just break the middle term and you have your answer. You should have the graphical approach knowledge of finding the solutions. Things become very, very easy. Rather than moving to the general formula and then finding out for what integers it is satisfying, it's better to move on for the graphical approach. Fine, especially for easy stuff like this. Okay? Let's happen to see the next question. 3 sides of a triangle. Okay, so triangle is being given to us. 3 sides of a triangle are 3 consecutive natural numbers. Okay, so this is given to me. The largest angle is twice the smallest angle. Then the sides of the triangle are what? Okay, so there is a triangle. Fine. There is a smallest side. Okay, and the largest angle is twice the smallest angle. Suppose this is the smallest angle, this is the largest angle. So this will be what? Pi minus 3 theta. Because all these angles, when I am going to add, I am going to get pi. If I know 2 angles, third angle is pi minus 3 theta. Understood? Now, let the sides are given to me. The only information is that they are 3 consecutive natural numbers. So let the sides be a minus 1, a and a plus 1, where a is a natural number greater than equal to 2. Why greater than equal to 2? Because if a is 1, a minus 1 will be 0, which is not a natural number. So to confirm that all three are natural numbers, for them to be the length of the sides, a has to be greater than or equal to 2. And all these are natural numbers. That is why I have taken a minus 1, a plus 1. 3 consecutive natural numbers are the three sides. Now a minus 1 is the smallest, so it is going to lie opposite to the smallest angle. A plus 1 is the largest, so it is going to lie opposite to the largest angle, and so this is your A. You know the sides, you know the angles. What is the rule which can help you relate them? It is nothing nonetheless but the sine rule. So you have, by sine rule, what is it that we can say? A minus 1 upon sine theta, a minus 1 upon sine theta is equal to a plus 1 upon sine 2 theta. This means a minus 1 upon sine theta is equal to a plus 1 upon 2 sine theta cos theta. Fine. Now theta is an angle from 0 to pi, 0 not included, pi not included. In 0 to pi, if you remember, this is how the graph of sine is when 0 and pi are not included. So sine theta for any angle between 0 to pi, 0 and pi not included, is strictly positive, and that is why I can cancel these two. So what you get cos theta is equals to a plus 1 upon twice of a minus 1. This is what you get. There's further some extension to sine rule. Let's now use that to get another condition. A minus 1 upon sine theta also a minus 1 upon sine theta is equal to a upon sine of pi minus 3 theta. But sine of 180 minus theta is same as sine theta. So this will be a minus 1 upon sine theta is equal to a upon sine of 3 theta, which is 3 sine theta minus 4 sine cube theta. Again you can take out sine theta common. A minus 1 upon sine theta equals a upon sine theta, you take out common, 3 minus 4 sine squared theta. Again these two can get cancelled for the same reason, and therefore you get 3 minus 4 sine squared theta equals a upon a minus 1. I have something like cos theta is equal to this. Here I have sine squared theta. Of course I can convert it into cos. What is it that I get? 3 minus 4, 1 minus cos squared theta is equal to a upon a minus 1. What is cos theta? A plus 1 upon twice of a minus 1. So you get 3 minus 4 into 1 minus a plus 1 whole square upon 4 a minus 1 whole square equals a upon a minus 1. Now this means what? This is 3 minus 4 plus 4 into a plus 1 whole square upon 4 into a minus 1 whole square is a upon a minus 1. 3 minus 4 is minus 1. This 4 gets cancelled. So minus 1 into a minus 1 whole square plus a plus 1 whole square whole upon a minus 1 whole square is a upon a minus 1. Cross multiply. What is it that you obtain? If you cross multiply, what are you going to get? You are going to get minus 1 into a square plus b square minus 2ab plus a square plus b square plus 2ab equals a into a minus 1. So what you get? Minus a square minus 1 plus 2a plus a square plus 1 plus 2a equals a square minus a. Fine. Minus a square plus a square gets cancelled. Minus 1 plus 1 gets cancelled. You have 2a plus 2a, that is 4a. So you get a square minus a minus 4a equals 0. That means a square minus 5a equals 0. A minus 5 is 0, but a cannot be 0. How can side's length be 0? Right? Over here, why were we able to cancel? Did you realize? Here basically on cross multiplying I cancelled a minus 1. 1a minus 1 I cancelled because a is not allowed to be 1. I have taken a to be greater than equal to 2. That is why we cancelled a minus 1. Over here, a is not allowed to be 0, but the product is 0. That means a minus 5 is 0. So a is 5, a minus 1 is 4, a plus 1 is 6, and therefore 4, 5, 6 are length of 3 sides. And therefore the answer is 4, 5, 6. This question from the solutions of triangle portion is not actually asking you to be using a very greater rule. It is just using sine rule twice to give you two conditions, incorporate what is given from the first condition in the second condition, get your answer. Fine. There are certain small intricacies which you have to take care of, otherwise this question is really very easy. Okay, that's it for today. Practice hard. Thank you.